Right, so this lesson is all about the addition formulae for trigonometry. Now, trig doesn't work like algebra does. When we've got a number outside a bracket in algebra, you all know by now that we expand and we make that 4x plus 4y. Now, it doesn't work for trigonometry. So if I've got two things like that within the bracket, that is not sine x plus sine y. The reason is this is an angle, and it's sine of the combined angle. Now, there was an exercise for you to do where you had to try and discover or prove the actual formulae, and this little lesson is all about how to use the formulae. So let's start with the first one. So these are called compound angle formulae or addition formulae. I'm going to start with sine of x plus y. Now it expands to, well, expands the wrong word, it becomes sine x cos y plus cos x sine y. Every time you have two things that are being added in the bracket with a sign, that is how we simplify it. Right, let's look at an example. So for example, I could say let's do sine x plus pi over 3. Remember, pi over 3 is radians and it's the equivalent of 60 degrees. Quickest way, 180 divided by 3 is 60. Right, now I'm going to apply this formula. There's my x, there's my y. So it becomes sine x cos pi over 3 plus cos x sine pi over 3. Now, using your special angle formulae, or special angles that you might remember from GCSE, or just using your calculator, we can simplify this. Cos of 60 is a half, so that becomes a half sine x. Standard practice says we write the number before the trig function so it doesn't look like it's part of the angle. It's just convention. Now, sine of 60 is root 3 over 2 cos x, and that is what sine x plus pi over 3 simplifies to. Right, how about x minus y? Well, it's very similar to the one above here. It actually becomes sine x cos y minus cos x sine y. So let's have a little recap here. If there's a plus between them, there's a plus in the middle. If there's a minus between them, there's a minus between them. So plus goes with plus, minus goes with minus. My old teacher used to tell me that the the S here stood for it stays the same. So the sign stays the same. Now you're given this formula in your booklet. Well, actually it's not a booklet, it's a sheet, but it's given like this. It's written as sine x plus or minus y is equal to sine x cos y plus or minus cos x sine y. It's just to make things a little bit simpler. The plus is on top here, so the plus matches with the plus, the minus matches with the minus. Right, now cos has its own set of values too, which hopefully you managed to figure out as well using that first task that I sent you this week. So let's look at cos. So we have cos of x plus y. Now, obviously, cos is different to sine, so the expansion or the addition formula is different. This one goes like this. It goes cos x, cos y, plus sine x, sine y, and I am wrong. Silly me. Sorry, minus. So, as my teacher used to say, the C stands for change. So if it's a plus here, it's a minus there. Cos, cos, sine, sine. So what would cos x minus y look like? Hopefully you can figure out that it would be cos x, cos y, as before. But this time I've got a plus sine x, sine y. This is going to be very important when we look at how to solve the r theta formulae, which we will do in another video. That's going to be next week's work. So cos x, cos y minus sine x, sine y, or cos x, cos y plus sine x, sine y. So the summary that you would be given is this, but this time the middle bit is going to be reversed. So because the plus was on top, the minus has to be on top, and because the plus is underneath, in this one, the minus is underneath. It's just a way of writing it simpler. Quite frankly, I think these are very easy to learn and you don't need to be able to do them. Now there's two more for tan. So tan of x plus y. Actually, let's do the two together and then I'm going to show you how to prove the tan formulae. So let's do tan x plus y. Well, that's going to be tan x plus or minus tan y. So if it's a plus, it's a plus. It's only cos it reverses the sign. Divided by 1 minus tan x tan y. Now we're going to look at how to prove that using the others. You could get asked to do this in the exam, so please take note of this proof. It's very important. I'm going to move this out of the way. I'm going to need paper because that wasn't big enough for me to be able to do it. Right, so here's my paper. Let's have a look. So we want to work out what tan x plus y is. Now in year 1, you learned that tan x plus tan was sine over cos. So that's the same as sine of x plus y over cos of x plus y. And what I'm going to do now is I'm going to use the addition formula at the top and the addition formula at the bottom. So at the top would give me sine x cos y plus cos x sine y. At the bottom, I'm going to have cos x cos y minus sine x sine y. Now, if you remember rightly, and I'm going to quickly pop this in front of you, we need tans. How are we going to get tans? Well, we know that tan is sine over cos. So we are going to divide the top and the bottom by cos x. Now we're allowed to do this because we're actually just multiplying by 1 if we divide the top and the bottom by the same thing. Remember to do it to everything. Sine x divided by cos x is tan x. Actually, let me write it out for you. So that's sine x divided by cos x times cos y plus cos x divided by cos x sine y. And at the bottom, we'll have cos x divided by cos x cos y minus sine x divided by cos x sine y. So I've divided every term by cos x. I can put it all over the whole lot. I've just opted to just put it over the first one. Hopefully you understand that it's exactly the same thing because this is multiplication. Well, sine over cos is tan. So that's going to become tan x cos y. This one cancels out, so I just end up with sine y. At the bottom, that cancels out, so I've got cos y. This one becomes tan x sine y. So I have my tan x's. I also need some tan y's. So how am I going to get tan y? Well, I get that by dividing by cos y. So I divided by cos x on the top and the bottom. I'm now going to divide by cos y. Why am I dividing by cos and not sine? Because I want tan, and tan is sine divided by cos. Right, let's see what we get. So I'm going to leave the tans alone. So I've got tan x cos y divided by cos y plus sine y over cos y divided by cos y over cos y minus tan x, missed my x there, sorry, sine y over cos y. I'm hoping you're looking at that and go, yeah, I know what's happening now. Well, let's check. The two cos y's are going to cancel. So we're going to be left with a tan x here. This is tan y. This is 1. This is going to become tan y. And there's the proof. Let's have a quick look. Is that what we wanted? Can you see both of them? There we go. Tan x plus tan y over 1 minus tan x tan y. Oh dear, sorry. forgot to put that in. That's going to make a big difference. That's going to be a plus minus situation at the bottom as well. Now we can prove using the minus versions if we need to, so be very careful to see which one they've asked you to do, whether it's to prove the plus or the minus.